Current flowing through a conductor creates heat. The conductor insulation may be damaged if this heat is not allowed to dissipate away from the conductor. Damage due to excessive heat may damage or destroy the conductor insulation. National Electrical Code rules and regulations are intended to prevent excessive heat in electrical circuits. Some of the provisions addressed by the National Electrical Code to prevent excessive heat are: conductor fill limitations, ambient temperature of the conductor environment, the conductor insulation temperature ratings, and box fill limitations. Let's examine the limitations set by the National Electrical Code for box fill. Article 314 of the National Electrical Code covers the regulations pertaining to outlet, device, pull and junction boxes, conduit bodies, fittings, and handhole enclosures. To understand box fill requirements, let's begin by examining the dimensions of standard electrical boxes and how these dimensions are used to limit damaging heat caused by electrical current. The number of conductors and devices allowed in an electrical box is determined by the volume of the box. The volume of standard metal electrical boxes are listed in Table 314.16a in the Electrical Code. The volume value of these electrical boxes allow for correct heat dissipation. Notice the volume value for the 4-square box shown. The volume is 18 cubic inches. Please note that this volume is found from the inside diameter of the box. The maximum number of conductors for each of the metal boxes is listed on the right-hand side of Table 314.16a. Please note that these numbers indicate conductors of the same size. Later examples in the video will solve for conductors of different sizes. The code requires additional conductor counts for items such as splices and devices. Let's examine the box fill requirements for typical wiring techniques. In this example, a 4-square box, 1¼ inch deep, is used as a pull box. In this example, all of the conductors are number 12. Using Table 314.16a for metal boxes, the code allows 8, number 12 conductors. This is a convenient way to reference metal box fill limits when all of the conductors are the same size. The code allows this type of fill count when the conductors in the box has no splices. The code references this in part in 314.16b1. 314.16, b1, conductor fill: each conductor that passes through the box without splice or termination shall be counted once. Let's now examine how splices affect the conductor fill requirements. The count for conductors that are spliced is covered in Article 314.16, b1. This states: each conductor that originates outside the box and terminates or is spliced within the box shall be counted once, and each conductor that passes through the box without splice or termination shall be counted once. A count is added for each spliced conductor. In the example shown, 2 wires are spliced with a wire nut. Each wire is spliced and originates outside of the box. The conductor count in this example is 4. Each spliced conductor adds a count for the box fill. In the example shown, the conductor box fill count is 6. Remember that each spliced conductor counts as 1. Let's examine a conductor fill example where some conductors are spliced while others are pulled straight through the box. In this example, 3 conductors are pulled straight through, while 2 conductors are spliced. The 3 conductors that are pulled straight through have a count of 3, while the 2 that are spliced have a count of 4. The total conductor count in this example is 7. The code makes special provisions for equipment grounding conductors in Article 314.16b5. The code states that for equipment grounding conductor fill where up to 4 equipment grounding conductors or equipment bonding jumpers enter a box, a single volume allowance in accordance with Table 314.16b shall be made based on the largest equipment grounding conductor or equipment bonding jumper entering the box. If more than 4, an additional quarter volume is required for each. It is important to select the correct size box for the conductor count determined by Section 314.16 of the Code. Let's examine how a box is selected by using conductor volumes. We'll begin with the code requirements when all of the conductors are the same size. The purpose of selecting the correct box size is so that the conductors in the box can dissipate heat away from the conductor. In order to accomplish this, the code requires a cubic inch volume requirement for each conductor size. This cubic inch volume value assures that each conductor is able to dissipate heat correctly without damage to the insulation. Let's examine the cubic inch box fill code requirements for conductors 18 through 6. As seen here, the cubic inch requirements increase as the conductor increases in size. For example, notice that an 18 conductor requires 1.5 cubic inches of volume while a number 6 conductor requires 5 cubic inches of volume. These volumes are for proper heat dissipation for conductors in a box. Table 314.16b of the National Electrical Code lists the volume allowance required for each conductor size from 18 to 6. The conductor volumes will be used to select an appropriate box size. The box size volume must be equal to or greater than the combined volume requirements of the conductors. Let's look at some examples of how conductor volumes are used to select an appropriate box. In this example, the conductor count is 10, number 12 conductors. Table 314.16b requires a cubic inch volume requirement of 2.25 cubic inches for each number 12 conductor. Multiplying these two values results in a total of 22.5 cubic inches. After the cubic inch requirement of the conductors is found, Table 314.16a is used to select the appropriate box. In this example, a box with at least 22.5 cubic inches must be selected. In this example, a box will be selected for a total of 9, number 14 conductors. Table 314.16b show that 2 cubic inches is required for each number 14 conductor. In this example, a box with at least 18 cubic inches is required. This volume number is then used to select an appropriate box from Table 314.16a. Selecting a box that contains different conductor sizes require finding the cubic inch requirements for each conductor. In this example, 2 number 10 conductors and 2 number 14 conductors are spliced. Table 314.16b lists the cubic inch volume requirement for each conductor. Each number 10 conductor requires a volume of 2.5 cubic inches. Each number 14 conductor requires a volume of 2.0 cubic inches. The cubic inch requirement for the number 14 conductors is 8 cubic inches. The cubic inch requirement for the number 10 conductors is 10 cubic inches. The total box volume cubic inch requirement is 18 cubic inches. This value is then used with Table 314.16a to select the proper box size. Article 314.16, B1, of the Code, identifies the conductor count when they are looped with no splice. Article 314.16, B1, states in part, each conductor that passes through the box without splice or termination shall be counted once. Each loop or coil of unbroken conductor not less than twice the minimum length required for free conductors in 300.14 shall be counted twice. Conductors may be looped in a box to provide for future splices. The conductor count of a loop depends on the length of the loop. Article 300.14 of the Code refers to 6 inches of free conductor at the box. If the loop length is 6 inches or more, each conductor is counted twice for box fill calculations. In the example shown, 5 6-inch conductors are looped in the box. The conductor count for this box is 10 conductors. Box volume calculations include the total box assembly. Box volume calculations in Code Article 314.16a states, the volume of a wiring enclosure, box, shall be the total volume of the assembled sections and, where used, the space provided by plaster rings, domed covers, extension rings, and so forth, that are marked with their volume or are made from boxes the dimensions of which are listed in Table 314.16a. The 4-square box shown here has a volume of 18 cubic inches. Adding an extension ring increases the volume of the assembly by the cubic inch volume of the extension ring. A raised cover for a device also adds to the total volume of the assembly. Please note that box fill calculations for devices will be explained later in this video. Box cable clamps may be required to be included in the box conductor count. Code section 314.16b, 2, states, where one or more internal cable clamps, whether factory or field supplied, are present in the box, a single volume allowance in accordance with table 314.16b shall be made based on the largest conductor present in the box. No allowance shall be required for a cable connector with its clamping mechanism outside the box. The metal switch box shown here has internal cable clamps. These clamps will add a single volume to the largest conductor count. The 4-square box shown here has an external cable clamp. No additional conductor count is needed for external conductor clamps. Allowance for support fittings are also included in the box fill conductor count. Article 314.16, B3, states, where one or more luminaire studs or hickeys are present in the box, a single volume allowance in accordance with table 314.16b shall be made for each type of fitting based on the largest conductor present in the box. Internal box items used for support of things like chandeliers and ceiling fans will add to the box fill count. Conductor fill requirements are also applied to conduit bodies. Article 314.16, c, addresses conduit bodies. 314.16, c, 1, states, conduit bodies enclosing 6 AWG conductors or smaller, other than short radius conduit bodies as described in 314.16 c, 3, shall have a cross-sectional area not less than twice the cross-sectional area of the largest conduit or tubing to which they can be attached. The maximum number of conductors permitted shall be the maximum number permitted by Table 1 of Chapter 9 for the conduit or tubing to which it is attached. Short radius conduit bodies, such as pulling Ls, are not allowed to contain splices. Article 314.16, c, 3, states, conduit bodies such as capped elbows and service entrance elbows that enclose conductors 6 AWG or smaller, and are only intended to enable the installation of the raceway and the contained conductors, shall not contain splices, taps, or devices and shall be of an approved size to provide free space for all conductors enclosed in the conduit body. Conduit bodies that allow splices must have the cubic inch space provided. Article 314.16, c, 2, states, only those conduit bodies that are durably and legibly marked by the manufacturer with their volume shall be permitted to contain splices, taps, or devices. The maximum number of conductors shall be calculated in accordance with 314.16b. Conduit bodies shall be supported in a rigid and secure manner. Remember that code sections pertaining to conduit fill and minimum conductor space apply to all conduit bodies. Part 2 of this video series cover the box fill requirements for non-metallic boxes and also conductor count for boxes that contain devices such as receptacles and switches.